Good afternoon, I'm Abdel-Razzak Merheb from the Lebanese International University, and I will be presenting my group's work entitled Development of a Freefall Precision Aerial Delivery System for Firefighting Applications. This is the plan of my presentation. After a short introduction, we will move up to the design requirements and see together the algorithms developed. We will see also some simulation and results, the experimental platform, and then I will conclude with some ideas and future work points. Forest fires affect severely the ecological system. These fires result in the loss of the home of a great number of insects, birds, animals, and even human beings. For example, in 2020 and 2021, in Akkar district, wildfires destroyed more than 3,500 hectares. And as you know, Lebanon is a very small country. Despite the efforts, fire took a long time to be extinguished, which result in a huge economic losses. And this means that using automated systems for firefighting will be an efficient solution. Actually, automated systems can reach dangerous and mountainous areas faster and easier than firefighters and heavy equipment. However, rotary wing UAVs are power greedy, which means that their effectiveness is decreased, and we will end up with the system with maximum flight of half an hour. In the Lebanese International University, we have been working on firefighting systems for several years. For example, we have developed a quadcopter swarm for forest fire surveillance. We have developed also a nearly fire detection system using UAVs and artificial neural networks. We developed also a very cheap fire station that can be hanged over trees, and then that can detect the starting of any fire in the forest. We also designed a blimp for forest fire detection and monitoring, but the blimp did not go beyond the design step because of COVID-19. In this work, we are proposing a freefall drone for firefighting missions. This drone should be of low cost, low power, very effective and very simple, and it will deliver extinguishing solutions to the fire location. It can be deployed in numbers, and it falls freely in the air and directs itself to the fire location. Our system includes a main drone or even a manned airplane or helicopter that will throw the freefall drone. This main drone is equipped with a camera looking downwards. This camera streams live video to the base station, which has a very fast computer. An image processing algorithm in this computer detects the fire location as well as the freefall drone location, calculates the error, and sends the error to an onboard computer in the freefall drone. This computer will use PID controllers in order to direct the freefall drone towards the fire location. The image processing algorithm is based on Python OpenCV program, and the drone is equipped with an array of infrared LEDs in order to be detected. The image processing algorithm detects the drone location and calculates the error between the drone location and the midpoint of the screen, which is assumed as the fire location, and the error is sent to the onboard PID controller in order for the freefall drone to direct itself towards the fire location. In Simulink, we simulated the drone equations that can be seen at the right hand of the screen. These equations are simulated in Simulink, and the drone is controlled the motion of the drone along y-axis and the rotation around z-axis are controlled, and two PID controllers are used in order to direct the drone, and the controllers are tuned by trial and error, and the gains are shown on the screen now. These are the simulation results, or the responses of the Y position and the yaw response. As you can see, the inputs are both step inputs. For the Y response, the rise time is only 0.3 seconds, and the maximum overshoot is about 3.75%. For the yaw response, which is the rotation around the z-axis, the rise time is only 0.5 seconds, and we have no overshoot. We produced two prototypes for the freefall drone, a smaller one made of degradable material, mainly cardboard, and a bigger prototype made of PVC for testing. And each prototype costs about or less than $35, which means that we have successfully developed a very cheap system for firefighting algorithm, for firefighting missions. Sorry. The tail of the freefall drone has a clipped delta blade shape with 4 symmetrical fins. These fins can be grouped into two groups. The first group is responsible for the rotation around the z-axis or for the control of the yaw angle, and we have here two blades, two fins that move in opposite directions in order to induce a torque that will rotate the freefall drone around its z-axis. The other group, the second group, is the second group of fins includes also two fins that are perpendicular to the first group. These fins move together up and down in order to induce a force for the drone to move along its y-axis. We developed also a parachute responsible for controlling the speed of the freefall drone, and in order to keep a constant speed while falling. The design, or we found that the best radius for the parachute is 87 centimeters, and the figure here is showing our parachute under test. We also had the static tests on the algorithm. As you can see in the figure here, a webcam detects the drone. We can see also the infrared LEDs. The light of these LEDs cannot be seen by bare eyes. So the webcam detects the LEDs, detects the drone, and the distance between the drone and the midpoint of the screen is detected. The error is calculated and sent to the onboard computer, actually microcontroller, in order to control the fins of the freefall drone. Now our work is a first step in the development of a freefall drone. This drone is very energy efficient, used for firefighting applications. We have developed two prototypes. The freefall drone can be loaded in any other drone or even a manned helicopter, and can be thrown in numbers over the fire area. The freefall drone will then be directed towards the fire location, and the drone will deliver its extinguisher mixture once impacting with the ground. We provide preliminary static indoor tests, and further development idea will be shown. Now, as a future work, finding the actual model of the drone is very essential. This can be found using system identification techniques. Developing a new intelligent image processing algorithm is very essential as well. For example, using artificial neural networks. that can detect the drone and isolate the drone and the fire. It is good to update the system with nonlinear control algorithms such as sliding mode control or fuzzy logic control to have a smoother and better robust tracking result. We are planning also to update the algorithms to be suitable for a swarm of free fall drones, which will increase the effectiveness of our system. This was everything, and thank you very much.